This is Pre-Calculus, Unit 2, Lesson 4, Inverse Functions. So that's what we're going to look at today. The idea of an inverse is that it undoes or takes us back to where we started. Let me give you a brief example. Let's say I've got this relationship here, where if I input 1, I get out 2. If I input 2, I get out 5. If I input 3, I get out 9. If I input 4, I get out 6. Okay? So the domain is 1, 2, 3, and 4. The range is 2, 5, 6, and 9. And if this is a mapping, you might call it, or a relation, right? It can also be considered a function because it does pass the vertical line test. Let's go ahead and graph it. I'm just going to do a little plus sign for the origin, 0, 0, 1, 2, 2, 5, 3, 9, 4, 6. Okay? And you can see that it passes the vertical line test, though it's discrete points. No vertical line touches more than once, so it does qualify as a function. Okay? Now let's at the same time map its inverse function. Inverse. Okay, so we'll call this f inverse of x. F inverse of x is indicated by this mapping. Input 2, you get out 1. Input 5, you get out 2. Input 3, you get out, input 9, you get out 3. Input 6, you get out 4. So in an inverse function, the input and the output have been exchanged or switched, right? And let's graph it. So 2, 1, 5, 2, 9, 3. Whoops, that's not 5, 2. 5, 2 is here. 9, 3. 5, yeah, 9, 3. So 1, 2, yeah, 5, 6, 7, 8, 9, 3. Okay. And 6, 4. 6, 4. Okay. Now, if you squint at this and look at it, you might notice there is some type of symmetry going on here, and there actually is. It'll become more obvious if I draw a diagonal line. This is the graph of y equals x. Y equals x forms a horizontal line, has a slope of 1. Okay. Here, let's just do this here. Y equals x goes like this. And it splits the graph right down the middle, and you'll notice something there that it kind of looks like a butterfly if you want. There is symmetry across the line y equals x, right? There are matching points directly across from each other. Mirror image, if you like. So it has y equals x symmetry. And that's very important to note. And basically, again, what's going on with an inverse function is we're taking the output of 1 and turning it into the input. Okay? So here's the definition of an inverse. Definition. F and G are inverses. If and only if. So it flows both ways. Both directions. F and G are inverses if this is true, and if this is true, they're inverses. If and only if f composed of g of x is the same as g composed of f of x equals x. Okay, let's use that in terms of this. Let's say this is f of x, and this is g of x. Okay. Okay, what is f of 1? F of 1 is 2, taking this point, right? What is g of 2? G of 2 is 1. So f composed of g of 2 is f of g of 2 is 1, and f of 1 is 2. Notice the input is the same. F composed of g of 2 is 2. So if I put in a number and calculate g of that number and then calculate f of the result, I'll end up back where I started. That's the idea. It really bears out the idea that inverse functions undo. Okay? And we can use that intuitive idea to find inverse functions. Okay? So let's do that here. Let's take an example. Let's take y equals 1. Let's do x minus 2 cubed divided by 4 plus 3. Okay, and let's think about this in terms of a function and what it does. If you think in terms of order of operations, it starts with x. We then take whatever x is, we subtract 2, because parentheses comes first. Then we cube, x cubed. Then we divide 4, and then we add 3, right? If we're going to undo or reverse the damage done to x by y here, by f of x we'll call it, we're going to do the opposite things in the opposite order. So instead of plus 3, we're going to minus 3. Instead of divide 4, we're going to multiply 4. Instead of cube, we're going to cube root. And instead of minus 2, we're going to plus 2, right? And so we're going to take x and we're going to do all those things to it, going in that order. Okay, so this will be f of x, and this will be f inverse of x. Okay, let's build our function. All right, and just to be consistent, we're not going to call it y, we're going to call it f of x. F of x. Okay, so f inverse of x, and that's the notation, f little negative 1 exponent. And we're going to start with x. We're going to subtract 3, right? Subtract 3. We're going to multiply 4. We're going to take the cube root of that, and we're going to add 2. Okay? So intuitively, these should be inverse functions. Let's bring up our Desmos calculator and see if that actually is the case. See if we get some y equals x symmetry. Okay? Graphing calculator. Okay. So I'm going to put in the function y equals x minus 2 cubed, all divided by 4, plus 3, and that would help if I said cubed and not squared. There we go. And let's graph the other one. Y equals cube root, CBRT, 4 parentheses x minus 3. Go out of the cube root, plus 2. Okay, and at the same time, we'll graph y equals x. Lo and behold, look at that. They are inverses of each other. Now, there is a more systematic way to do it, but I like this intuitive way. Think in terms of doing opposites in reverse order. Okay, but there is an algebraic procedure way, right? And here, let me show you that real quick. If y equals x minus 2 cubed over 4 plus 3, your first step is to switch the x and the y. Right? So we write x equals y minus 2 cubed over 4 plus 3. By the way, in terms of x and y, you've already got an inverse. Let me demonstrate here. Okay? I'm graphing y equals x minus 2 cubed over 4 plus 3. What if I graph x equals and just type the same thing, but just switch x and y? Divide 4 plus 3. I get the same graph, right? Now, so all that remains really is to solve for y. And the reason why this works is when you solve, you do the opposite steps in reverse order. Opposite of minus 3 or plus 3 is minus 3. Y minus 2 cubed over 4. Multiply 4, 4x minus 3, y minus 2 cubed. Opposite of cubing is cube root. Cube root 4x minus 3. Avoid distributing because I want to preserve the opposite operations in the opposite order. And then add 2. Cube root 4x minus 3 plus 2 equals y. And there we go. So you end up with the same thing. So switching the x and the y really gets you the inverse already, and then you've just got to solve for y. Now that can be easier said than done. All right, so let's say, I'm debating which examples to show you here. Let's say I've got this function, f of x equals x plus 2 divided by x minus 4. Okay, we can even graph it. Okay, let's bring up our Desmos graph and graph it. Y equals x plus 2 divided by x minus 4. We can see it's a hyperbola. It has a vertical asymptote at x equals 4 because it's undefined at x equals 4. It has a horizontal asymptote at looks like 1. Actually, yeah, the horizontal asymptote should be at 1. X over x rounds to, divides out to 1. That's for a later topic. All right, but we need to find an inverse function, a function that reflects over y equals x, right? And you can imagine that's going to be another hyperbola, but it's going to be shifted over to a different location. So here are the steps, and I'm just going to go through them fairly quickly. So we're going to start with y equals x plus 2. Feel free to stop this at any time to catch up. I'm going to multiply both sides by x minus 4. So yx minus 4y equals x plus 2. And that was, again, I just did this. I did multiply by x minus 4. Multiply by x minus 4. Okay, and I distributed yx, whoops, yeah, and minus 4y. My 4's look too much like y's. All right, and now I'm going to get all the y's to one side, or actually, I need to switch the x and the y, don't I? Switch the x and the y. Back up. I forgot to switch the x and the y first. Switch the x and the y. Yeah. Over y minus 4. And by the way, I have accomplished it technically by doing that. Just that. X equals y plus 2. Divide y minus 4. There it is. There's the graph. But that's not proper function notation, right? And so we got to solve for y, and that's the tricky part. So multiply both sides by y minus 4. I get xy minus 4y equals y plus 2. Get all the y's to one side, right? X, yeah, x okay to do. All the y's to one side, and there we go. I'm doing something wrong here. XY. Oh, 4x. That's what's wrong. I knew there was something weird. 4x. There was an extra y. Get all the y's to one side. Okay, so by subtracting y from both sides and adding 4x to both sides, we're going to get xy minus y equals 4x plus 2. Factor out a y. There's a y in both of these terms, and what's left is x minus 1. So y times x minus 1, 4x plus 2. Now divide by x minus 1. Y equals 4x plus 2 divided by x minus 1. Okay, let's see if that worked. Let's see if we didn't blow it somewhere here. So y equals 4x plus 2 divide x minus 1. Lo and behold, there it is. Yeah, all right. It's always a good feeling when you have success. Feel free when you're doing these, finding inverse functions, graph them. Graph them along with y equals x. That's a great way to check to make sure you did it right. All right, I'm going to leave off domain restrictions and one-to-one. Basically, the idea is that a function must pass a horizontal line test in order to have an inverse function. Otherwise, you may have to do domain restrictions, but we're going long on this video. All right, have a great day.